Hello, everyone. Welcome to our presentation. Our project is Beyond Pair Programming, How Experts and Novices Navigate the Knowledge Gap with Pair Data Analysis. With me here is, I'm Andrew, this is Brenda, this is Achintya. Satvika and also Sam also heavily contributed project, but they're not here today. We're from UC San Diego and we're part of the Data Science Teaching and Learning Lab. So imagine you got a summer internship at a research lab. You just got settled down and they hand you some data sets. But you're not a biology minor. You find yourself asking, what is the best way to handle missing values in this context? How do I visualize this data? How do I interpret the patterns I am seeing? When dealing with unfamiliar domains, these are the kinds of questions that usually require some additional digging beyond just pulling from classroom knowledge. So this is a classic classroom to practice gap. And this is quite common in many situations. In school, we see data science students being wizards at syntax, but the moment they are faced with a messy, unstructured, real-world problem, they start to struggle. The problem is usually conceptual and strategic. They get stuck asking, what does this data even mean? And more importantly, what am I supposed to do next? This isn't just our observation, it is a well-documented challenge. There is a growing call in the research community to bring these authentic, messy problems into the classroom to better prepare students for these exact hurdles. Naturally, people might look to the obvious solutions, the powerful AI assistants that we're all seeing, like Gemini and Google Sheets or GitHub Copilot. These tools are fantastic at being task completers. They can instantly generate code, clean a column, or answer a specific factual question. They can solve the immediate problem. But there's a limit. They are good answer givers, but bad mentors. They give the students the final product, but bypass the process, the productive struggle that actually builds long-term skill. This approach risks promoting superficial learning and over-reliance. And this isn't just theory. Recent research is beginning to show that over-reliance on these tools can lead to cognitive offloading and diminished independent learning skills. These papers are literally from like this year. So, given those challenges that I just mentioned, our goal was very clear. We wanted to build a tool that can provide guided mentorship, and we knew this tool had to be embedded directly into the data science workflow right inside Jupyter Lab, where students are doing all their work. This brings me to our tool, which we call WISE, the Watchful Intelligent Science Expert. So, WISE is a powerful AI mentor designed to guide data scientists through the ambiguity of early stage analysis, offering expert level domain aware insights, smarter EDA suggestions, and task specific support right inside your notebook. It helps you make sense of messy data sets, identify unusual patterns, and interpret complex domain specific columns, all while reducing the barriers to exploration. So even if you lack background knowledge or domain expertise, like the example I mentioned before with biology, with WISE by your side, you can approach any EDA with clarity and confidence. Our design was guided by three key principles. Number one, ease of use. Novices often don't know what to ask, so our tool will proactively assist them instead of waiting for a prompt. Number two, data-specific analysis. We built features that target the most common bottlenecks in a data science workflow, like parsing, terminology, and graph trends. Number three, we use a flexible architecture. We built the tool to be modular, making it easy to add new features as our research evolves. So, ready to see what the demo looks like? Will it play? Okay, so let's walk through a common data analysis scenario. We'll be working with a real-world air quality dataset. So immediately we hit a common hurdle, confusing domain-specific column names. For example, what is PM 2.5 and RSSI DBM? This is an issue for the user. When they open the WISE sidebar, the extension has proactively identified these terms and provided concise, plain English explanations. This potential blocker is cleared instantly. Next, the user's job is to check data quality, especially for missing values. This is usually a time-consuming manual process. But WISE has already analyzed the dataset's completeness. It flags the columns with missing values, and more importantly, provides context-aware recommendations for how to handle them, like using interpolation for time series data instead of just dropping the rows. Finally, let's look at strategic guidance. The user creates a plot to see sensor records over time. But the graph is noisy. It's not immediately clear why it has so many extreme spikes and dips. Is this a real event or is there just a ton of error? WISE provides an insight, suggesting the potential cause for these anomalies. In this case, it correctly identifies that the issue is likely sensor malfunction, which is the actual ground truth for the dataset. This guidance prevents the user from going down the wrong analytical paths. As you can see, WISE helps the user move from confusion to understanding at each step of their EDA. It provides all this guidance just by reading the information in the Jupyter Notebook with no additional context. However, for more advanced use cases, we also provide an interface for users to enter specific goals or background information to get even more tailored help.
Okay, so now that we've seen how WISE is, let's figure out how does it work behind the scenes. Essentially, first let's follow a user workflow. So let's say the user is working on the notebook and the user requests help from the WISE tool. What we'll first do is the front end takes the entire notebook state in a JSON file and sends it to the back end. This includes all the things such as metadata, output cells, input cells, and everything. And then we perform three major steps. The first is keyword extraction. Essentially, we run some tokenization and regex algorithms to find some candidate keywords. And these keywords might be accurate, such as RSSI DVM, or they might be not useful, such as entry ID. Now what the job of the LLM is, it's to one, find out the relevant keywords. And the second job is to define these relevant keywords. Now these keywords can be stored and later be sent back to the user. The second step is data frame analysis. As you saw in the demonstration just now, there was a data frame that was displayed in the output cells. What WISE now does behind the backgrounds is first it takes these data frames from the output cells and it normalizes the data. It performs some basic data operations. And then finally it sends it to another LLM who is also given the keywords to get more context on the problem. And then finally it can generate some insight. Finally is the plot analysis. Now this is similar to the previous two, however there's an extra step that's involved. First what we do is we take the plot from the notebook and then without any context we ask the LLM to tell us about the features of the plot. For example, we might tell it where's like the most noise in this data and perhaps why is there can you identify where like a huge spike or a huge dip might be. After we get these features, we send this to another LLM in a multi-agent system. And essentially what we tell it is, okay, now here's the features that we want to know answers for, and here's the context of the plot, and here's some keywords that you should go off of. And given all this, it can generate an output and give you some insights about the plot. Finally, all of this is bundled together and sent back to the front end, and the front end can simply display this back to the user. So now, a few advantages of this architecture that we chose. One was modularity. As you know, we had three different features: the keyword extraction, the data frames, and plot analysis. And we made it in such a way so that you can easily add more new features and remove features that you don't want. Alongside this, we also have the decoupled front-end and back-end architecture. This allows for easy development, and alongside this, it forces a standardized data format for communication, which helps us make code cleaner. Finally, there's also the reusable context. As you remember, when we extract the keywords, there's actually two uses for that. One is to display to the user and show it these are the definitions of the keyword. And the second usage is for giving context to the LLMs for the plot and data frame analysis.
Because our WISE was designed to have novices to work on those exploratory data analysis with the unfamiliar data sets or data domains, we want to first make sure that this kind of support that we offer will truly help the students or the learners. So before jumping into the testing WISE directly on students, we decided to run some observational study to observe how experts naturally get novice through those real data analysis tasks. So with this goal in mind, we conducted an observational study guided by our research question here. How do experts help novice data scientists make sense of and work effectively with data from unfamiliar domains? So for this study, we paired 7 domain experts with 7 data scientists. So all the experts are PhD researchers with different areas of expertise. For example, some are specialized in data privacy, others are like climate science, stuff like that. And each of them actually created a domain-specific data analysis task in Python based on their own research interests. And the novices were all third-year data scientists, undergrad students, who are unfamiliar with both the domain and the dataset itself, which make it a little bit challenging for them to go through those analysis tasks. So I would like to give you an overview of how we designed each observational sessions. So each of those sessions will last about an hour to an hour and a half. And we started with like a short pre-observation briefing where we just gave an overview of the study structure and introduced the participants to each other. Then we'll move on to the second phase, which we so-called the introduction phase. This part was led by the experts themselves who introduced the dataset, provide some background and context, and also described the exploratory data scientist test that the analysis test are going to be working together. And then once the novice is ready, they start with the text execution. So this part will take about 30 minutes, where the novice will start sharing their screen and walk through the test while the expert provide any verbal guidance as needed. And meanwhile, our research team here will take notes on some of the key interaction moments, such as point of confusion, breakthroughs, or any type of support that seem to help, whether through analogies, metaphors, guiding questions, or real-life examples. And finally, after the study, we conduct a short post-test interview with both the experts and the novice separately to ask them to reflect on their experience overall. So now how we actually analyze our data. So we start by transcribing the data from the video recording. And after we got those transcripts for data analysis, we decided to use semantic analysis. Here, we carefully review the transcripts to identify any recurring patterns, expressions, and insights. And from there, we create a set of initial codes to capture those key patterns and observations across the data. After that, we compare and refine those codes, and we begin grouping them into some broader themes that highlight the main takeaways to answer our research question. So we organized our findings into 6 main themes, which I compiled here, starting with establish domain context and build rapport, and identify knowledge gaps, encourage thinking, validate and correct, and then lastly, give clear explanations. So over the next few slides, we will walk through those themes one by one. So the first key takeaway here is that experts prepare novices to work with unfamiliar data by first establishing the domain context. What it means is like experts often start by explaining the important concepts and any technical terms so the novice can understand the data and what the data actually means. And then they will start connecting the dataset back to some real-life examples to explain why the data matters, how it was collected, and who it actually impacts in everyday situations. So once this foundation is set, novices start to see the data as more than just numbers and code itself. So they begin to see the bigger picture and then start to draw more meaningful insights as they work through the data analysis. So let's see some code together. So this one is provided by one of our experts saying, when I say carbon dioxide, that's CO2. CO2 is the chemical formula and carbon dioxide is the chemical name. So you can see here the expert is trying to give some explanation on the technical term to help build this foundation for the novice to understand the data field. Another example here will be this expert trying to give an explanation on the sleep pressure. So he could use a real-life example here. If you lose a lot of sleep one night, your body will fall asleep quicker and spend more time in deep and REM stages. So actually, this data set, REM stages is one of the field in the data set. So to help the novice actually make sense of the data, this expert trying to provide a lot of real-life examples. Next, we would like to go through how experts actually build this rapport with the novice. So they tend to use a lot of encouragement, especially towards the beginning of this observational study, to help those novices build confidence. For example, they keep saying, oh, your thought process is excellent, you're doing great, and just a lot of confirmation to help them to build a sense of motivation and confidence. At the same time, when the novice actually run into issues or challenges, they will use a lot of reassurance to help reduce the anxiety. For example, they'll be saying, oh, that's okay, you just need to work through it as a challenge, or you're really close to the correct answer, you just need to do this and that. So you can see that the expert during the study is constantly trying to make effort to build this like close connection with the novice. Lastly, we realized that when the experts help the novice make progress, it usually follows a cycle of 4 steps, which we will call an adaptive feedback loop. So this cycle starts with identifying the knowledge gaps, which means that after introduction, introduce the data set with the expert, with the novice and start working on the data analysis together, they can quickly notice where the novice actually struggles and what they don't yet understand. And then, instead of giving the direct answers, they will encourage some self-reflections or self-thinking by asking a lot of prompting questions and guiding questions. And once the novice start to share their thoughts or thinking process, the experts will either validate or correct, which means if the novice is actually on the right track, really close to the correct answer, they confirm what is correct. And if not, they will gently point it out and clarify what is wrong. Finally, after this process, if the novice is still stuck and not making any progress, the expert will walk through the solution with a lot of explanations and details step by step. What is really interesting here is that this is an adaptive feedback loop. As the novice make progress or run into new challenges, experts keep adjusting the amount of help and the type of support based on how the novice responded in the last subtask they've been working on together. So what can we take away from this study? First, AI mentor tools likewise should mirror the adaptive nature of human experts. So when we talk about adaptive support here, we mean being able to adjust the type and the level of help based on what each learner needs in that moment. The key is knowing when to step in to help the learners and when to step back and trying to encourage some self-reflection. And this is something that's really easy for human natures, but much harder to capture in the algorithms. Second, instead of simply giving the right answer, AI mentors like Wise should help the students think through the reasoning process. So those systems should be designed in a way to encourage the learners to explain their thinking, reflect on their approach, and connect what they learn to new situations. So in this way, students in the future can build stronger and more transferable reasoning skills that they can apply to new domains or even new data sets or even new subjects. Lastly, for educators like us, it is really important to help students connect data and concept to real-world examples. When students understand what they learn can actually apply beyond the classroom setting, they naturally become more motivated and engaged with those data analysis tasks. Also, we always encourage educators to use adaptive scaffolding by giving support that matches students' need. So offering more help when the students are struggle, and gradually our role is trying to step back as the students get more and more confidence. Lastly, we want to make sure to encourage students with positive feedback and reassurance. So a supported environment helps the students to feel more confident, motivated, more willing to take risks, and keep trying even when tests or things are getting more difficult.
So now a few challenges and limitations we faced during our work. One was moments of silence. This is specifically a challenge in what we wanted to do. One thing that would be immensely helpful for this tool is if you could identify when the novice is struggling, aka moments of silence. For example, let's say you're working through a data set and for the past minute or so you haven't made any progress at all. How can we identify that and then preemptively step in and help the novice? This is one challenge that we want to solve. Another limitation of our study is our basically our study sessions with the expert and novice domain pairs. We had a ton of domains ranging from climate change to cancer cells to sleep cycles. And this was on purpose because we wanted to make sure we're not focusing too much on one specific task. However, a problem with this is that these domains require many different tasks, they have different data analysis techniques, and they have different difficulties of the tasks themselves. This makes it really hard to compare all these different ones, and there's really no standardized thing we can do here. And as for our future work, first thing we want to do is conduct a large-scale quantitative study. Basically, we want to have two groups of students, one who are given the tool and the other who is not, and we want to see, does our tool really help students, and what are some places where it might be lacking or we could improve it. And finally, we want to make WISE more adaptive and dynamic. As previously mentioned, a good tutor should be adaptive and dynamic, and therefore our tool should also do the same. What this means, if let's say the novice is really running through the dataset and they're doing really well, you want to tone down our help and basically not interfere as much. Otherwise, we want to, if they're struggling, we want to make sure we step in early and help them as much as they need.
Okay, finally, as a summary of our presentation or our project, the problem that we faced was that novices were struggling with analysis strategy and knowledge gaps. The tool we created to address this was called WISE, and it is a proactive Jupyter Lab extension built to be a guiding mentor. To find out more about the human expert novice pair interactions, we conducted a study to see what exactly makes effective mentorship. And lastly, our key findings are experts adapt, they guide strategy with questions, and build confidence with validation. So this is the end of our presentation, and so we're happy to connect more to answer questions, or if you'd like to contribute or collaborate on the project, feel free to reach out. We are also happy to share code or share our code base.